The bomb. On January 23, 1961, a B-52 bomber took off from Seymour Johnson Air Force Base in North Carolina for a routine airborne alert mission. It was carrying two Mark 39 hydrogen bombs, each one roughly 250 times more powerful than the bomb dropped on Hiroshima. This was standard practice during the Cold War. Bombers stayed airborne around the clock, fully armed, ready to respond to a Soviet strike at a moment's notice. The crew had flown missions like this dozens of times before. Nothing about this flight was supposed to be different. A few hours into the mission, the crew noticed something wrong. Fuel was leaking from the right wing at an alarming rate. The leak worsened. Within minutes, the aircraft had lost over 37,000 pounds of fuel, and the pilot lost control. The order came to abandon the aircraft. As the B-52 broke apart in the night sky over Goldsboro, North Carolina, its two nuclear weapons separated from the wreckage and began to fall. One bomb's parachute deployed correctly, and it landed relatively intact in a field. The second bomb did not. It plunged into the mud near the Nahunta swamp at high speed with no parachute to slow it down. Investigators who later examined the wreckage found that 3 of the 4 safety mechanisms designed to prevent an unintended detonation had failed during the fall. Only one switch, a single low-voltage arming switch, stood between the bomb and a multi-megaton explosion over American soil. That switch held. Engineers who studied the incident decades later said the bomb came within a hair's breadth of detonating. Parts of the weapon were never recovered. They remain buried in the swamp to this day, sealed off under a permanent easement. The government bought the land and has monitored it ever since. No press conference was held, no public warning was issued. For years, most Americans had no idea how close North Carolina came to becoming the site of an accidental nuclear detonation, until declassified documents confirmed it decades later.
The false alarm. On September 26, 1983, Stanislaw Petrov reported for a quiet overnight shift at a secret bunker outside Moscow. His job was to monitor OKO, the Soviet Union's early warning satellite system, designed to detect an American nuclear missile launch the instant it happened. Tensions between the two superpowers were at one of their highest points of the Cold War. Just 3 weeks earlier, the Soviet military had shot down a Korean civilian airliner, killing everyone aboard, and both sides were on edge. Petrov's job that night was simple in theory. If the system detected an incoming launch, he was to alert his superiors immediately so they could decide whether to retaliate. Just after midnight, the alarms went off. The screen showed that the United States had launched a single intercontinental ballistic missile aimed at the Soviet Union. Then it showed a second missile, then a third. Within minutes, the system was reporting 5 incoming missiles, all heading towards Soviet territory. Soviet protocol was clear. A confirmed launch was supposed to be reported up the chain of command immediately, triggering a retaliatory strike. Petrov had only minutes to decide what to do. He had a phone in his hand and a direct line to his superiors. Something about the reading bothered him. A real American first strike, he reasoned, would likely involve hundreds of missiles, not 5. He made the decision not to report it as a confirmed attack. He told his commanders it was a system malfunction, an unverified glitch, and waited. The minutes that followed were the longest of his life. No missiles arrived. It was later confirmed that the satellite system had mistaken sunlight reflecting off high-altitude clouds for the heat signature of missile launches. Petrov's decision likely prevented a retaliatory nuclear strike that could have started a full-scale nuclear war. He received no medal. He was quietly reprimanded for failing to properly document the incident, and the event was kept secret for over a decade. The submarine. In October 1962, during the height of the Cuban Missile Crisis, a Soviet diesel-powered submarine designated B-59 was patrolling the waters near Cuba. American naval ships had detected it and were dropping practice depth charges nearby, trying to force the submarine to surface so they could identify it. What the American ships did not know was that B-59 was carrying a nuclear-tipped torpedo, and that its crew had been cut off from radio contact from Moscow for days. Inside the submarine, conditions had become unbearable. Temperatures had climbed past 100 degrees in some compartments. The air conditioning had failed, carbon dioxide levels were rising, and the crew had not received orders from Moscow in days. When the depth charges began exploding near the hull, the captain believed war had already started above the surface. Soviet protocol allowed the captain to launch the nuclear torpedo if he believed the submarine was under attack and could not reach headquarters, but only with agreement from 2 other senior officers aboard. 2 of the officers gave their approval. The torpedo was nearly armed. 1 man disagreed. Vasily Arkhipov, the submarine's second-in-command, refused to authorize the launch, arguing that the depth charges was signal charges, not an actual attack, and that they should surface and try to re-establish contact instead. The argument grew heated below decks while the explosions continued above. Arkhipov held his position. Eventually, the captain backed down and the submarine surfaced instead of firing. Decades later, historians who reviewed the incident concluded that a single officer's refusal had likely prevented a nuclear exchange between the 2 superpowers. Arkhipov died in 1998, largely unknown outside military history circles. Many of the people walking around today owe their existence to a decision made in a sweltering submarine that almost no one heard about until years afterward. The solar storm. In July 2012, something happened in space that most people on Earth never heard about. And the scary part is that we were just 9 days away from being in a completely different world today. The sun had an incredibly violent outburst. It was a massive cloud of charged particles shot out from its surface at incredible speed. We call this a coronal mass ejection. This particular one, on July 23rd of that year, was not a normal one. Scientists later measured it and found it was one of the most powerful ever recorded, possibly stronger than anything seen in over 150 years. Now here is where things get uncomfortable. The cloud missed Earth, but only because our planet had moved past that exact spot in its orbit about 9 days earlier. Had the eruption happened just over a week sooner, the charged particles would have slammed directly into Earth's magnetic field. Researchers who modeled the potential impact concluded that a direct hit of that magnitude could have knocked out transformers, satellites, and power grids across the globe. Some estimated the recovery could have taken years, not days, with damages reaching into the trillions of dollars. There would have been no warning beyond a day or 2, no way to prepare beyond shutting down vulnerable infrastructure and hoping it held. Instead, the storm passed harmlessly through empty space, detected only by a solar observation satellite that happened to be positioned to record it. Almost no news outlets covered it at the time. Most people went about their July as if nothing had happened, because for them, nothing had. Somewhere in an empty patch of space, a storm strong enough to reset modern civilization burned itself out, 9 days too late to matter. The training tape. On the morning of November 9, 1979, technicians at NORAD's command center in Colorado watched their screens display a full-scale Soviet nuclear attack against North America. The system showed missiles launched from submarines and land bases, all converging on the United States. Military officials were notified immediately. Bomber crews were sent to their aircraft and put on alert. Air defense interceptors were scrambled into the sky. The National Security Advisor was woken up and informed that a nuclear war may have just begun, and he had only minutes to decide how to advise the president on a retaliatory response.
Officials scrambled to verify the attack through a second system before recommending a counterstrike. The verification did not match. Satellite sensors that were supposed to detect missile launch heat signatures showed nothing unusual happening in Soviet territory. Confusion spread through the command center as officers tried to determine which system was telling the truth. After several tense minutes, technicians traced the cause. A training exercise tape designed to simulate a full Soviet nuclear attack for drill purposes had been accidentally loaded into the live warning system. The computers had displayed simulated missiles as though they were real, and for several minutes the people responsible for America's nuclear response believed the country was already under attack. The scramble was called off. The bombers were stood down. No missiles had ever been launched. A congressional investigation later criticized the incident, along with several similar false alarms that occurred in the following months, and called for stricter separation between training systems and live detection systems. The fixes took years to fully implement. For a few minutes on a quiet November morning, the only thing standing between peace and catastrophe was someone double-checking a second screen.
The briefcase. On January 25, 1995, Russian military radar detected a rocket launching from an island off the coast of Norway. It was climbing on a trajectory that resembled an American submarine-launched ballistic missile, the kind used to deliver a nuclear warhead. Russian early warning systems flagged it as a possible attack. For the first and only confirmed time in history, Russia's nuclear briefcase, the device used to authorize a nuclear launch, was opened and activated in front of President Boris Yeltsin. Military officials informed him that the rocket appeared to be heading toward Russian territory, and that if it was a nuclear strike disguised as a scientific launch, a response would need to be authorized within minutes. Yeltsin had less than 10 minutes to decide whether Russia was under nuclear attack. The rocket continued climbing. Officials tracked its trajectory carefully, watching for separation events that might indicate multiple warheads breaking off toward Russian cities. As the seconds ticked by, it became clear the rocket's path would carry it away from Russian territory rather than toward it. It was, in fact, a Norwegian scientific research rocket launched to study the aurora borealis, and Norwegian officials had notified Russia about the launch weeks in advance through diplomatic channels. The notification had not reached the right people in time. The rocket fell harmlessly into the sea north of Norway, exactly as planned. Yeltsin closed the nuclear briefcase without giving any launch order. The incident remained largely unknown to the public until years later, when officials confirmed how close the miscommunication had come to triggering a nuclear response. A weather rocket studying the northern lights had, for 10 minutes, been mistaken for the opening act of a nuclear war. The meteor. On the morning of February 15, 2013, residents of Chelyabinsk, Russia, were going about an ordinary Friday when a streak of light tore across the sky, brighter than the sun. A meteor, roughly 20 meters wide, had entered Earth's atmosphere undetected, traveling at nearly 19 kilometers per second. No telescope, no satellite, and no early warning system had spotted it coming, because it had approached from the direction of the sun, where ground-based observatories are effectively blind. The object began to break apart roughly 30 kilometers above the city, releasing energy equivalent to around 500 kilotons of TNT, dozens of times more powerful than the atomic bomb dropped on Hiroshima. The shock wave that followed shattered windows across 6 cities. Over 1,500 people were injured, most from flying glass as they rushed to windows to see the bright flash. Roofs collapsed under the pressure wave. A zinc factory lost part of its wall. Remarkably, no one was killed. Scientists later noted that had the object entered the atmosphere at a slightly steeper angle, or survived intact rather than breaking apart at high altitude, the damage on the ground could have been catastrophically worse. Space agencies around the world were tracking thousands of known near-Earth objects at the time, and not one of them had flagged this rock as a threat, because no one knew it existed until it was already burning through the atmosphere. In a strange coincidence, an entirely unrelated and much larger asteroid was making a scheduled close pass by Earth that very same day, drawing the attention of nearly every astronomer on the planet. While the world watched the sky for the asteroid everyone knew about, the one nobody saw coming arrived first. The meltdown. On March 28, 1979, operators at the 3 Mile Island nuclear power plant in Pennsylvania were monitoring a routine night shift when a relatively minor mechanical failure occurred in the cooling system. A valve that was supposed to close after releasing pressure failed to do so and remained stuck open. Instrumentation in the control room incorrectly indicated that the valve had closed properly. Operators, trusting their gauges, had no way of knowing that coolant was steadily draining out of the reactor core through the stuck valve. Over the next several hours, the reactor core began to overheat as it lost the water needed to keep it cool. Confused by conflicting readings, operators made a series of decisions based on incomplete information, including reducing the flow of emergency cooling water at a critical moment, unintentionally making the situation worse. Roughly half of the reactor core began to melt. It was, at the time, the most serious accident in the history of American commercial nuclear power. Radioactive gas began venting from the plant. Pennsylvania's governor ordered a partial evacuation of pregnant women and young children from the surrounding area as engineers scrambled to understand what was happening inside a reactor core no one could see. For a tense 48 hours, officials were not certain whether the situation could be brought under control before a full meltdown breached the containment structure. Engineers eventually stabilized the reactor before that happened. Studies conducted in the years afterward found no statistically significant increase in cancer rates among nearby residents, though debate over the long-term health effects continued for years. The incident reshaped nuclear safety regulations across the country and effectively halted the construction of new nuclear plants in the United States for over 3 decades. A small stuck valve, misread on a gauge, came within hours of a different and much darker outcome.
The asteroid. On July 25, 2019, an asteroid roughly the size of a football field passed by Earth at a distance of about 73,000 kilometers, closer than many communication satellites in orbit. Astronomers gave it the designation 2019 OK. Had it struck a populated area, scientists estimated it could have leveled a city with the force of a large nuclear detonation. The asteroid had not been discovered until the day before its closest approach, despite multiple observatories around the world actively searching the sky for exactly this kind of object. It had approached from a direction near the sun's glare, where reflected sunlight makes faint objects extremely difficult to detect with ground-based telescopes. By the time it was confirmed and its trajectory calculated, the asteroid was already nearly upon Earth, leaving almost no time for any kind of public warning, let alone a response. Brazilian astronomers were among the first to spot it, just hours before it became visible to telescopes in other parts of the world. Scientists later described the object's discovery timeline as alarmingly short, noting that current detection systems are still not equipped to reliably catch every object of this size before it arrives. Had its path been shifted by even a small margin, it would have entered Earth's atmosphere with virtually no warning at all. It passed by safely and continued on its orbit around the sun, unnoticed by almost everyone except the small group of astronomers who happened to be watching the right patch of sky at the right moment. Most of the planet went about that Thursday with no idea how close it had come to a very different kind of headline. If history is full of disasters that happened, it is just as full of the ones that almost did. Subscribe if you want to keep finding out how close we've come.